Hello, class. So today we're going to look at GPS 21, which is Introduction to Systems of Linear Equations and Solving Graphically. So let's just skip to a problem. So basically in this GPS, we're going to have two equations instead of one. Okay? So let's just go straight to an example. Okay, let's go straight to 21.4. So basically, when you have a system of equations, this is what we call a system of equations here. Okay, this is called a system of equations. All right. Basically, it's a system of equations when there's more than one equation, right? Here, there's two equations, so we call that a system of equations. So, what is a solution to the system of equations? So, here they want us to check: is the point -2, 1 a solution to the system of equations? So, how do you know if it's a solution to the system? Well, then this point -2, 1 has to satisfy both equations for it to be a solution to the system. Okay, so let's see if it satisfies both equations. So here we're told that the x value is -2 and the y value is -1. So we're going to plug it into both equations. So first we're going to plug it into the first equation. Okay, we're going to plug our point into the first equation. So that would give us -3 times -2 plus -1 equals to 5, right? So if we work that out, this is going to give us a 6, and then plus and minus become a -1 equals to 5, and 6 minus 1 is 5 equals to 5. So check. All right, so you see this point works for the first equation, okay? Now we gotta check, does it work for the second equation? So same thing. We're gonna plug x and y into the second equation. So we would have 6 times -2 plus -1 equals to -4. So 6 times -2 is -12 minus 1. Right? Plus minus become a minus equals to -4. And this gives us -13 equals to -4. And as you can see, they're not the same. So it doesn't work here. Right? They're not equal. So it does not work. So then the question is the point -2, 1 a solution? Okay, so is -2, 1 a solution to the system? The answer is no. Okay, because like I said before, a solution to a system has to satisfy both equations, right? This point, okay, -2, -1 only satisfies the first equation. Okay, for it to be a solution, it must satisfy both equations. All right, let's look at the second one, the next one. Okay, so now they're asking you to check. Now they're saying, well, is -1 to a solution to the system of equations? So now, same thing. We're going to take the first point. We're going to plug it in. Okay, that's our x and that's our y. So is -1 to a solution? Well, we got to plug it into both equations. So the first equation is going to be -3 times -1 plus 2 equals to 5, right? We're plugging it into the first equation. That's going to give us a +4 plus 2. Oh, I'm sorry. That's not +4. That's a +3. That's a +3 plus 2, right? -3 times a -1 is a +3 plus 2 equals to 5, and 3 plus 2 is 5 equals to 5. So check. So it works. So this point satisfies the first equation, okay? Now we got to check, does this point, does our -1, 2 satisfy the second equation? We're going to plug it in. That's our x and that's our y. So it'll be 6 times -1 plus 2 equals to -4. So 6 times -1 is -6 plus 2 equals to -4. And -6 plus 2 is -4 equals to -4. And check. You see? So our point -1, 2 satisfies both equations. So is -1, 2 a solution to the system? The answer is yes. Okay, why? Because it satisfies both equations. Okay, so again, for a point to be a solution to the system of equations, it has to satisfy both equations. It can't just satisfy one, like you see in these two examples. Okay, let's go to another one. And that's kind of what this is saying right here, right? The point must satisfy all the equations, okay, for it to be a solution. All right, so now we're going to look at solving systems of equations graphically, okay? So how do we solve a system of equations graphically? Basically, or when you graph the two lines, okay, the solution to the system is the point of intersection. Okay, when you graph these two lines, they are going to intersect at a point. The point where they intersect is their solution. Let's see how that works. Okay, so let's look at 21.7. So on 21.7, we're basically going to graph both the equations, right? So here's one equation right here, negative 3x plus y equals to 5. And the second equation is here, 6x plus y equals to negative 4, right? Here are our two equations. We're going to graph both of them. So let's graph the first one. How do we graph it? We have to solve for y, right? We need to use slope and the y-intercept. So we're going to solve for y. How do we solve for y? Plus 3x to both sides. Right, so we get y is equal to 3x plus 5. And we can tell the slope, right? So this guy is our m, this guy is our b. So the slope here is 3 over 1. The y-intercept is 0, comma 5, right? You guys should remember that from the previous GPSs. And let's plot this point. Okay, so we have, so remember how to plot this? You start the y-intercept. So we have 0, 1, 2, 3, 4, 5. So boom, that's our y-intercept. Okay, and we're going to follow the slope. What does the slope say? Go up 3 because it's positive and go right 1. Okay, so we're going to go up 3 and then right 1. So 1, 2, 3, right 1. There you go, that's our point. Let's label them. Okay, so this point is 0, comma 5, and this one is 1, comma 8. Okay, and we're going to connect those two dots. All right, so our line looks something like that. And let's label this. This guy is negative 3x plus y equals to 5. All right, now we're going to plot the second point. Okay, so now we're going to take the second equation and then again, we're going to solve for y, right? We're going to plot it. We're going to have to find the slope and stuff. So solve for y, minus 6x to both sides. So what do we get? Y equals to negative 6x minus 4. Okay, and then here is our slope. Here is our y-intercept. So what's the slope? It's going to be negative 6 over 1. And our y-intercept is going to be 0, negative 4. Okay, and then let's plot our second line, which is at 0, negative 4. 1, 2, 3, 4. And then that's 0, negative 4. And then you're going to go down 6. So it's going to be 1, 2, 3, 4, 5, 6, and then right 1. So about right there. Okay, let's label that. This is 0, negative 4. This guy is 1, what is it, 8, 9, 10. Okay, and then let's connect the two lines together. Okay, it should look something like this. Okay, and as you can see, the two lines intersect, right? Two lines intersect right here at this point. All right, so what's that point? That point is actually negative 1, 2. Right, that's negative 1, 2. So that's our solution. So the two lines intersect at negative 1, comma 2. Okay, that is our solution. Let me write it better. That is our solution. Okay, so that's basically how you do that. So let's look at another one. And then here they want you to substitute to check, right? We did that already, actually. That's the same line as the previous problem we were doing. You see, right? Same one as before. Solution was negative 1, 2, right? Same equation. Okay, so I'll leave that up to you to check. Let's look at the next one. Now the next one, we're pretty much going to do the same thing, right? So we're going to take the first equation, right? And then we're going to solve for x. So how do we solve, solve for y, I meant. Solve for y, right? You want to plot using slope, so we're going to solve for y. What do we do? Minus 3x to both sides. Okay, that cancels out. We're left with 6y equals to negative 3x plus 12. And then divide both sides by 6, right? And then everyone gets the 6. So we get y is equal to, and 6 cannot divide 3, so we just reduce, right? So it's going to give us a negative 3 over 6, pull the fraction aside, x plus 2. And if we reduce, we're going to get y equals 2, reduced by 3. So we're going to get 1 half x plus 2. So what's our slope? Slope is negative a half. What's the y-intercept? 0, 2. Okay, and then do the same thing for the next equation, right? Solve for y, minus 6x to both sides, minus 6x. So we're going to get negative 2y equals to negative 6x plus 10. Divide both sides by negative 2. Divide both sides by negative 2. So we get y equals to 3x minus 5. So what's the slope? Slope is 3 over 1. What's the y-intercept? 0, negative 5. Right? So now we're going to graph. All right, so first we're going to graph the first equation. So we have 0, 2. We're going to be 0 and then 1, 2. So that's the y-intercept for the first equation. And we're going to follow the slope, right? Slope says go, what does slope say? Slope says go down 1 because it's negative, and then right 2, right? Slope is negative a half. So we're going to go down 1, right 2. So let's do that. We're going to go down 1, right 2. 1, 2. There's a point right there. One more time. Down 1, right 2. 1, 2. One more point right there. Okay, so there you go. Those are our points. Let's just label them. So this guy is 0, 2. This guy is 2, 1. And this guy is 1, 2, 3, 4, 0. And we're going to label the line once we graph it. Okay. So let's try to, so again, you should use a ruler or some kind of a straight edge, right? And make sure your line is going to be straight. Otherwise, you might not get the right intersection point. Okay, so try to use a ruler, make sure your line is straight and passing through all your points. So it's kind of hard for me to do on the computer, as you can see. Okay, but when you're doing it by hand, use something straight. Okay, that looks okay. Now, we're going to plot the second equation. So the second equation, again, okay, we're going to start with y-intercept, which is 0, negative 5. So 1, 2, 3, 4, 5. 0, negative 5 is right here. And then we're going to go up 3, right? So look at my slope. My slope is positive. So I'm going to go up 3 and then right 1. So I'm going to go up 3, right 1. So I'll go 1, 2, 3, right 1. There you go. That's a point. And then let's do one more time. 1, 2, 3, right 1. There's my point. Okay. So let's connect the dots. All right. Again, you want to try to make them as straight as possible so you get the correct intersection point. Right? Right, that's okay for now, I guess. Good enough. And where do you notice that these two lines intersect? Actually, we should label them as well too, right? So we don't get confused. This guy is 2x minus 2y equals to 10, and the red is 3x plus 6y equals to 12. Okay, and we can see that their intersection point is actually right here, right? Okay, so the solution to the system is 2, 1. Okay, that's the solution to a system. Now we can fill out the rest of the stuff over here. The two lines intersect at 2 meter. The lines intersect at 2 comma 1. And then the things that the question on the bottom, they want you to check it, right? So you should check this, right? So I'll leave that up to you to check. But basically, our solution is 2, 1, right? So plug it in. That's your x and that's your y, right? You want to plug it into your equation. Same thing here. Your solution is 2, 1. That's your x, that's your y. Plug them in. Okay, they should be equal. So I'll leave that up to you. Okay, let's go into the next one. All right, so for this problem, we're pretty much doing the same thing. We're going to take the first equation, x minus y equals to 6, and we're going to plot it, right? So we're going to solve for y. So minus x to both sides. So that comes out, we get negative y equals to negative x plus 6. And we can't have negative y, so divide both sides by negative 1. Divide both sides by negative 1. So we get y is equal to negative, negative turn into a positive. So it's going to be a positive x, and then a minus 6. So what's the slope? The slope is 1 over 1. What's the y-intercept? 0, negative 6. Okay, second equation, you have x plus y equals to 2. Solve for y, minus x to both sides. So we get y is equal to negative x plus 2. And that's it, actually. So what's the slope? Negative 1 over 1. What's the y-intercept? 0, 2. Okay, same thing as before, pretty much. So let's plug the 2 points. So for the first one, we have negative 6. So 1, 2, 3, 4, 5, 6. Here's my y-intercept. And I'm going to go up 1, right 1. So up 1, right 1. There you go. Up 1, right 1. There you go. Okay, and let's plot those points. This is 0, negative 6. This one is 1, negative 5. This one is 2, negative 4. Okay, connect the dots as accurately as possible. Okay, let's see. Oops, oops, that's not what I want. Okay, let's try that again. Oops. Right. Okay, so again, there you go, looks pretty good. So again, you should use a ruler or some kind of a straight edge to connect your dots, all right? Otherwise, you're not going to get the right answer. So again, use something straight, a ruler, your ID card, some kind of envelope or something straight, okay, to make your lines. Now let's plot the second point. Second point is 0, 2, right? So 0 and then 1, 2, I'm over here, that's the y-intercept. And I go down 1, right 1, so down 1, right 1. And then down 1, right 1. Okay, again, I'm just following the slope, right? Down 1, right 1. Right, so here, this was down 1, right 1, right? The positive slope, so you're going up 1 and then right 1, right? So let's connect the two, let's connect the points. Okay, that looks pretty good. And I'm going to label my line. This guy is x plus y equals 2. Okay, and we see that they intersect. Where do they intersect? They intersect right here. Okay, that's the solution. What's the solution? It is 4, negative 2. Okay, there you go. That's a solution, 4, negative 2. And again, you can check it if you want, right? If you want to check, if you want to do a check, right, you're going to plug in 4, negative 2 into both equations, right? So I'll leave that up to you. Solution. 4, -2. Okay. All right, let's do the last one. So pretty much same thing, right? So we're going to take the first equation, 3x plus 2y equals to 6. Again, plot it. We got to solve for y, right? So use slope and stuff. So solve for y. So we get 2y equals to negative 3x plus 6. Divide both sides by 2. So we end up with y equals to, pull that fraction out, negative 3 over 2x plus 3. So what's my slope? Slope is negative 3 over 2. Y-intercept is 0, 3. Okay, next line, I'm going to take my second line, 3x plus 4y equals to 0, minus 3x, minus 3x. So we get 4y equals to negative 3x, divide both sides by 4. So we get y equals to negative 3 over 4x. So my slope here is negative 3 over 4. My y-intercept, there is none, right? So it's going to be 0, 0. Now let's plot the 2 points. So we'll start with the first one. We start at 0, 3. So 0, 1, 2, 3, right here. Okay. And I'm going to follow my slope. Go down 3, right 2, right? Negative slope. So I'm going down. So 1, 2, 3, right 2. 1, 2. There you go. And then we'll do one more time. 1, 2, 3, right 2. 1, 2. Boom. So those are my points. So that is 0, 3. This guy is 2, 0. This guy is 1, 2, 3, 4, 4, 1, 2, 3. This guy is 4, negative 3. Okay, I'm going to connect the 2 dots. I mean the 3 dots. And look something like this. Again, you should really use a straight edge. I have no choice. I kind of freehand it. This is 3x plus 2y equals to 6. Second line, I have 0, 0, so I start 0, 0 over here. Okay, and I go down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. There's my point. Okay, there's my point. And that's strange, whatever. Point, and I go 1, 2, 3, 1, 2, 3, 4. There's my other point. Okay, so let's label our points. So this guy is 0, 0. This guy is 4, negative 3. And this guy is 8, negative 6. Okay, we're going to plot our point. Okay, again, you should use a straight edge. I have no choice. I'm going to have to sketch it here as best as I can. Okay, and as you can see, they intersect, right? This guy is 3x plus 4y equals 0. Okay, and as you can see, they intersect right here, right? So the solution for this one is 4, negative 3. Okay, so that's the solution to the system of equations. And again, if you want to check that, right, you plug in 4, negative 3 into both equations, and it should check out. Okay, and that's it. So again, if I lost you anywhere, just replay the videos again, pause it when you need to. And any other questions, you can post it on the discussion forums. So I'll see you guys next time.